Okay, so this is a new update that I have recently released. I've noticed that a lot of users, or I should say potential users, would like to try out the Tycho software, but they might not have a dedicated graphics device installed in their machine. And so to that end, I have found that there's actually quite a lot of functionality in the software that can still be used with just a regular CPU. So I put together a short demonstration here. The first thing is you can go to a device selector. So when you go here, you'll notice that there is now a new checkbox. It says check here to use only CPU. And as it states, this will be slower, but useful if you do not have a compatible GPU installed. So when you check this box, you are now in what's called CPU only mode of operation. And when you click test device, you'll notice that it says it has passed the test. And all that means is that it forgoes the normal GPU operations and instead routes everything through the CPU. So what this ultimately means is that every aspect of the software can now be accessed and used just with the normal CPU, including synthetic tracking. Now I will say that particular feature, I would highly recommend having a dedicated graphics card if you want to do synthetic tracking. But if you wanted to, you could use that feature even in CPU only mode. Now if you do have a dedicated graphics card installed, then as before, you would select it from the list, and when you run test device, you'll notice that it goes through some basic GPU operations, and this is done to verify that the card meets minimum requirements and so forth. But for the purpose of this demonstration, we're going to pretend as though we have only a CPU installed. And so I'm going to go ahead and check that box and click OK, and then proceed with loading the images. So I'm going to go view images, and you'll notice that this takes a bit longer than normal, and that's just because it's computing a median background layer, and that's sort of an operation that would take a lot less time if we were on the dedicated GPU. But nevertheless, it will carry on as normal. And this particular data set, again, there are 60 images here, having dimensions of 1536 by 1024. And this is actually the same data set that's in the Tycho user guide. In other words, it's the example data set. So you could follow along in this example if you wanted to. There are actually several asteroids in this field of view, but we're only going to look at one just to keep this simple. So here's an asteroid right here, and you'll notice as I scroll through the images, you can see the motion of the asteroid. So what we would like to do is create some measurements of this asteroid. So we're going to load the star catalog, and we'll go ahead and create a measurement here. So I double click on the object in the frame and click create observation. So we now have one measurement, and we'll go ahead and create two more measurements. So one right here, and then we'll do one more over here. So we now have three measurements of the object. These include the timestamp of the measurement, the position information, so right ascension and declination, and finally the magnitude of the object. And so I click this button here, this adds these to a target list. So this is one target, if you will, and this now shows a new window. So this is a list of all targets, and right now we have only one asteroid, but we have three measurements of this particular asteroid. If we wanted to, we could also create a report. So this would be formatted, in this case, in the MPC 1992 format. So you could submit this to the Minor Planet Center and so forth. Of course, you wouldn't want to do that for this demo because these are just demonstration measurements. But this, again, this shows you all the functionality that you could do in GPU mode, you can now do in this CPU only mode of operation as well. Another thing we could do is we could load the MPC orbital database, and this will show us a list of all known objects in this field of view. So this comes back with a list of known objects. So if I click on this one, now you'll notice it takes a bit of a while to respond, and that's because it is creating a stack according to the motion of the object. So creating a stack of images, this is something that again would be much faster with a dedicated GPU. But anyway, you can see it still worked. Just for reference, under a dedicated GPU, that operation would have taken less than 1 second. But as you notice, it took several in CPU-only mode. In any case, you can see the asteroid here, and that the stars are streaked, so it created that stack according to the motion of the object. And this is also, as you can see, the same asteroid that we actually just created measurements of. So what I can do is I can modify, I can edit the designation associated with these observations. And so this is object 38826. So that is the permanent ID of the asteroid. It is a numbered object, so we specify that. And what this allows us to do is we can then compare these observations with other observations that have been submitted on this object. So you can see this comes back with a list of lots and lots of observations that others have submitted, and that's just quite typical with a numbered object that's been around, has been known for some time. So anyway, we can now view this in the Find Orb software. I'm getting a bit more into the details here, so this is stuff that you would become more familiar with as you work through the software. But again, I'm just showing this for example purposes. So September of 2018, again, that's when these images were taken. So the first timestamp here, 55279, that's what we're interested in. And then 61582, and then finally 62640. So these are the 3 measurements that were just recently created, and these 2 columns denote the error in arc seconds for right ascension and declination. So anything under 1 arc second is considered a good measurement. As you can see, this is 0.11, 0.15, 0.19 is the highest here. So these are all very good measurements. So in other words, in the CPU-only mode of operation, you can take a set of images, you can create measurements of an object, you can validate those measurements and so forth. And so there's a lot of functionality here that you can make use of in CPU-only mode. You can view the object profile. This shows you the signal versus the noise and SNR ratio and so forth, the centroid. So all this information, what you would normally get in the astrometry program, is accessible again in this CPU-only mode of operation. But, anyway, that's all I have for now, so thanks for watching and see you next time.